final example that we'll take a look at in 1.4 day 1 is this one with domains. So we're doing compositions, and we're also going to consider the domain with those compositions, and they basically follow the same rules as the combinations with domain. You always want to use the most restrictive part of the domain as kind of your guide here. So it may or may not be different than the individual domains. We'll just have to see as we go through. Now, first of all, I've indicated here that we want to find the domain for each of these basic functions. So we've got x squared minus 1. That one doesn't have any restrictions on it. It doesn't divide by 0. It doesn't have any square roots. And so we can just say the domain is everything. Now, again, you might be used to saying all real numbers and that fancy R, but in pre-calc, I do want you to go negative infinity to positive infinity as a way of stating all real numbers. For g of x, looks like we do have a divide by 0 problem here. We can't have x equal to 1, so our restriction is x not equal to 1, which makes the domain everything except for 1. So think about going from negative infinity to positive infinity, but we're going to shoot a hole in there at 1, so it just goes to 1. That's a hole, so we put a rounded bracket around it, then we start right back up at the same point, 1 to infinity. So it just creates a break at that point if we have that restriction. Now it says, what is the domain of f of g of x? So fog of x. That is, as I mentioned in the last example, I like to just change that to this, so it's a little bit more clear that g of x is going into f of x. All right, so just establishing what this one is first. We've got f as the skeleton, or as the framework for this one. So it's empty space squared minus 1. That represents our x squared minus 1. We got to fill in g of x inside here. So that's our composition. We would want to simplify that by distributing that square to both of those. That means that we'll have 1 over x minus 1 squared and minus 1. All right, so you could distribute that through and everything and have it displayed as a polynomial in standard form, but this is probably a better way to just see all the restrictions. So let's leave it like this in this particular problem. Notice that the only restriction here, even though this is squared, it's the same restriction as what we had up here for g of x. Otherwise, we don't see any restrictions besides that, meaning that the domain of this one is actually going to be exactly the same as the domain of g of x up here. That doesn't mean it's the same graph, it just means that the restrictions are the same and the domain is the same. If we want to take a look at the graph, you could certainly graph that on your calculator and you will see some differences, but the domains end up being the same.